There we go. All right, so we talked about operations of functions last time. We're getting into composition of functions. So as you can see, when we're talking about composition of functions, we're basically saying you're going to get the result from the inside function, which then we are going to use to calculate the outside function. So they're basically saying the output of one function becomes the input for another function. So you actually do this calculation in two parts. You start by solving the inside function first. The answer you get from that is what we're going to use for the outside function. So the inside function in this case here would be the g of x, and then the outside would be f of x. You can obviously reverse that relationship and make f the inside function and g the outside function. This little notation is what we call as f of g, because we're using the f function with the g function inside of it. If I reverse that relationship, it's called g of f. And you will see that's a little open circle that we're using between our two functions. So it's not like your multiplication, where if you were just multiplying two functions, we would use a little dot. But when we're talking about composition, we have that little open circle in there, okay? So that's basically how we know that we're not doing multiplication, we're doing composition. And again, the definition for that composition ends up looking like this in function notation. Now, right here in this little remark here, we're basically talking about how composition is different from multiplication. So multiplication, remember, you just take the first function multiplied with the second one. That's not what composition does. The composition takes the second function and actually puts it inside of the first function. Okay, so it's not multiplication at all.
So you'd solve like the g of x first,
The inside function.
and then you'd solve the
Afterwards, taking the answer that you got from the g of x function. Okay, and that's basically what this little illustration here is talking about. So it's showing us how that composition between f and g works. G is the inside function. The outer function is always going to be that first one that's written down, right? So start by taking whatever x value you have, put it inside of the inside function, right, which is g, get the answer from that calculation, and then take it to the outside function. So what happens in this case, when we talk about the domain for the entire composed function, we're basically saying the values for g of x that you get, make sure they're going to be in the domain of the f function. So we'll again take a look at this with numbers and examples. So we're starting out with a set of ordered pairs again, and the way they're asking us to calculate this is they're saying find g of f. G is the first function that's written down, which means g is going to be the outside function. F is the second function that's written down, right? It's g of f, which means f is going to become your inside function. So again, when you're looking at composition, when they are asking you to find g of f, g goes on the outside, f goes on the inside. Okay, and they're asking us, okay, so they're in general asking us to find g of f, and they're also saying what's the domain going to end up looking like. So since f is the inside function, let me go ahead and write these definitions down. We're given f as 2, 0, 4, 0, and 6, 8. G as 0, 7, and 6, 0. Okay. So again, guys, f is the inside function, which means you need to start out with the f values first. So what's the first ordered pair in the f function? 2, 0, which means we will actually be starting out at f of 2. What does f of 2 give us?
0.
0, because you're finding the pair that it goes with, right? So the way this works with your composition, we have G of f of 2, which is where we start out first. F of 2 gives us 0. So that answer now actually becomes the input for the G function. Then you go to the G function and find the ordered pair with 0, which will be 7. Yeah, and that's going to be this first ordered pair here. So you actually end up getting the answer of 7.
Where did 7 come from?
G,
Oh, okay.
right? Yeah, because you started out with f of 2, which means we go to the f function, find the ordered pair where your x is 2, right? That means your pair is going to be 0. That's where this 0 came from. Now, with composition, the idea is, again, start with the inside function, which was f of 2. F of 2 gives us 0, so that's where this 0 came from. But now this 0 becomes the input of the outside function. And our outside function is g, because that's how they're giving us the setup of our composition here. They're asking us to find g of f. So this answer that we got from f will now go inside of g, and then you go to the g function, find the ordered pair where x is 0, and then find its y value, which gives you 7. Okay? But the way composition works, and this is kind of like what we had done with our operations of functions last time, the first x value I started out with was that 2 that I first began my calculation with. And I ended up, by the time I finished my composition, at 7.
Why do we choose to?
Because that was the first ordered pair in function f. In this case, yeah, because they didn't give us a specific value. They just said find g of f, so we go in order. Yeah, just start from the first. It will depend on the specific question. But they will not randomly start at the middle unless they specifically ask you to find f of 4. But yeah, otherwise in the general form like this question is, start from the beginning and go all the way through the end. So that means our second ordered pair in the f function is now 4, 0, right? So we will be repeating that process, but now we will be using f of 4. And what does f of 4 give us? 0 again. So same calculation with your composition. Yep, because you're going with f of 4. F of 4 also gives us 0, which means you're back at g of 0. And then g of 0 will take you to the same ordered pair, right? 0, 7. So you're going to end up at 7 again. So now your ordered pair is 4, 7. You know what?
We do it for all of the ordered pairs?
Every single one for the f function, yeah. So which takes us to which last point? 6. So what is f of 6? Good. Going in order, all of them, every single one of them.
Is that all we needed to do for ordered pair?
In the general form, yes. Because they didn't tell us find g of f at this x value, right? They just said find g of f. If they wanted a specific value, then they would have given you g of f at 2 or something like that. If they wanted it at a specific number, then you would only use that ordered pair. But since they didn't give us that specific, they just said find basically g of f. That means you're finding the whole function. So start at the first point and keep working till it doesn't work anymore, I guess, or you come to the end.
Question, so the third one is 6, 8,
Right.
but you're switching, finding the 6 on both x values, so it's different, right?
Right, so you're going to the f function and looking for the ordered pair with the 6.
Which is an 8.
Which is an 8. So now the 8 will go inside of the g function.
Right.
But then you go to the g function and find the ordered pair where x is 8.
There is not one.
There's
There is not one, yeah, because I've got 0 here and I've got 6 here, right? There's no 8, which is what I was kind of getting at with this discussion. So if the value you got inside the function is not in the domain of the outside function, you can't use it.
So it's just 2.
Exactly, because since we don't have an 8 that goes with the g function, there's actually no answer here, which means this guy actually will have to be left alone because I don't have a matching pair.
Now, do you have to go through all that, or can you just look and see that,
If you're confident that there's no answer, then you don't have to.
because you're gonna match the y's, right? There's no 8
And there's no, the x,
or the,
because you're looking for the x value in the g function, right? So
right.
these two numbers.
Well, no, because at first we looked at 2, 0, and we looked for the 0 over at g, right?
Yeah, but the 0 for the f function, which was the y value, became the x for the g function. Remember what I said, the output becomes the input. So this output of 0 becomes the input for that outside function. Because the idea is you solve the inside function first, right? Get an answer. That answer then has to go with the outside function. So f of 2 gave me the output of 0, but 0 became the input for g.
And that's where we got 7.
And then the 7 was the output.
That makes sense to me, but in the third one,
Mm-hmm.
you have 6 in the x value,
Uh-huh.
which would bring you over to the second set. Shouldn't the 6 be in the y value then?
Did you have the same 2 in here? Or the 4 in here?
No, when I used the 2, I went to the 0, and then I found the 0.
From the g function,
So.
right?
It kind of
No, you're not confused. Just follow along your path. You started with f of 2. You got 0 from that ordered pair.
Then I went over to the other set,
G function,
and I started with that 0.
but it was in the x position, wasn't it? The first
Yes.
position. Right.
And
And then the 0 gave you the 7, which was the pair.
Right.
Okay. So then same thing, you're starting with 6 in the f function, which gives you the pair of 8. Now 8 is what you should be looking for in the g function,
I
right?
can't find it, so it's.
We can't find it, so you can't complete that step. Yeah.
So there's kind of like process of elimination when it comes to, if we just took a look at the f section and took a look at it and just looked at the y's of it
Mm-hmm.
and said, does any of these y's fit any of these g's on the x side?
Mm-hmm.
And if they don't, we don't work.
Then
have
that
to go-
ordered pair cannot
Yes.
be used.
I
There
felt
you
like
go.
you were just doing too much.
No, I mean, again, the idea is since they asked us to find the general function, we have to make sure we go through all the ordered
We
pairs.
can't just look at it and say,
I mean, but you're doing the same thing, right? Even when you're
Right.
looking at it, you're still making sure you're getting all the pairs, and the ones that don't match, like 8 doesn't, you leave it out. So yeah, I mean, I'm doing this formally. You're just talking about looking at the sets and making sure that if something's not there, you don't use it. So
Okay.
it's the exact same thing. I'm just going through of writing it down, and you don't have to. Yeah. So the idea is just make sure you are getting all the values that you can solve and go all the way to the g function and get an answer from that, right? So now that we know that the third point I can't use, and there are no more ordered pairs in the f function, right? Which means I can't go any further. So this is it. Now you just have to write your answers down. So the g of f function, which they're asking us to find, is going to be these two ordered pairs you came up with, the 2 and 7, and the 4 and 7. This is your finished function. Because again, we couldn't use the 6 or the 8 or any of those pairs.
So then your domain would be 2 and 4.
Very nice, domain. Yeah. Well, in this case, remember, you're not doing interval notation because this is only 2 numbers, right? So you're just writing it as a set of 2 numbers. So in this case, since we are just using ordered pairs, you don't have to worry about interval notation. So you're using set notation with the, I don't know what those are called. Sure, squiggly sounds good.
so you don't have to go 2 to 6, it's 2 to 4. It's what's
Just the
your
number 2 and just the number 4, right? Because there's nothing in between that we know is going to work or
answer
not
for both of them.
for both of them. Yes.
On the exam, do you want us to amend how we did, or that we, you know, what
To show me at least how you came up with those ordered pairs? Yes, please. Yeah. Okay, so again, remember, starting with a set of ordered pairs is just to show you how we go from one function to the other, what works, what did not work, you leave it out, and then how to come up with your domain. So remember, since I only have 2 ordered pairs in my composition here, I have 1 pair here and 1 pair here, which means I have 2 x values and 2 y values. So my domain would be 2 and 4. What would be my range?
7.
Just the number 7, because that repeats. Yeah. There you go, and that's it. So no interval notation to worry about when it comes to domain and range for this example. But now in number 5, that's going to change a little bit because they're not giving us ordered pairs. They're giving us the equation definition itself. So you've got G and H, but look at how different this example is. Because now they're specifically giving us an X value, right? They're saying find the composition 4, 5, one way or the other. In example 4, they just said in general, find G of F, which means you have to go through all possibilities. In example 5, they're saying I only want specifically for X equals 5.
So you just plug in 5.
After you do the composition, So let me go ahead and write this down and then I'll show you how to break this guy down. So you are number 5. They're telling us G of X is the function square root of X minus 1. And H of X is the function 2X. They're asking us to find G of H at 5, and they're actually also asking us to find H of G at 5. Okay. So what I actually want to do is I want to show this to you in 2 different ways. So they're specifically asking you at 5, but what if they just said find G of H or find H of G without that 5 in there? Then how would we do it?
You do it with the negatives, you make it 1, 0.
No. You're talking about like if we were graphing it, right? No. So again, they want this in the generic way, not specifically at a number, let's say. So let's say they asked us to find G of H and H of G. So they didn't give us the 5, and we'll come back to that 5 at the end. So let's go with the first one. If they're asking us to find G of H in the generic sense, G is going to be the outside function. H becomes the inside function. Nope, you're not multiplying. Yeah, so that's kind of what that little remember remark part is talking about. It's not multiplication, okay? So what you're going to do, H of X is given to us as what value? 2X, right? So you're actually going to replace the inside function H of X by what it's given to us. And it's given to us as 2X. Now this is function notation, guys. Remember what I told you. If they put a little baby elephant in here, that's what you should be putting in your G function. So everywhere that you see X is going to be replaced by 2X. So everywhere you have an X has to be replaced by 2X now. So when you write this, you should have square root, because that's where the GX function starts. Instead of X, you should have 2X there, minus 1. Okay, so again, we're doing the composition G of H. H is the inside function, G is the outside function. So instead of H, replace it by whatever is the equation itself, which is 2X. So now we're saying G at 2X. So in the G function, wherever you have an X, that has now been replaced by 2X. Very good. And then the 5 will replace the x. So now when they say find, well, g, just for the x
Yeah.
value, yes ma'am, definitely. So this is where you would now have square root, because we already have the definition, 2, replace the x with the 5, minus 1, and you can now solve this. 2 times 5? 10 minus 1? And square root of 9? There you go. So this ordered pair, we started at 5, and where did we end? At 3. Question on this guy.
So as long as they give us a number to work with, that's always gonna be our X value.
Yeah, and if they didn't give you a number to work with, then you would just stop right here. So this would be for your g of x general terms. When they're saying specifically, like in our case, then this would be your answer. Yeah. Now remember, you're reversing that relationship.
When you say, that would be your answer, your red, rectangle,
Yeah, so the red would equal the red.
that also means right beside it, G2x would also be part of the answer.
No, because this was just us breaking the problem down, but your final answer for this question would be this. Your final answer for this question would be that number 3. So in between is just our steps that we broke down. Okay. Okay, so be careful now, because when we reverse that relationship between h and g, your function is going to change. Because now they're asking us to find h of g. And again, let's do this at a generic level first. So now h is the outside function, g is the inside function. So what is g, the original g function, defined as? Square root, right? So that guy will now replace the g of x. So this becomes the input for your h function, which means this whole thing, the square root of x minus 1, is going to replace the x in the h function. So actually, it's just going to replace this guy. So my h is 2 times x, right? It's going to become 2 times whatever is inside the parentheses. So it's become 2 times square root of x minus 1. Or you can actually write it without the parentheses, because it's 2 times square root of x minus 1. So just by changing that relationship between h and g, look how different these two functions look. This one was square root on the whole thing, 2x minus 1 on the inside. This guy here, 2 is on the outside, and then you have square root of x minus 1. So composition, because it follows that order of what functions on the outside and what functions on the inside, if you change that order, your composition comes out looking very different. You're not going to get the same answer for 99% of your examples. Okay, so this will be for our, then you plug in 5 for x. Yeah, so this is our answer.
4 is 2.
2 on the outside, okay, square root of 5 minus 1, which is 2, and 2 times 2 is 4. So as an ordered pair, very good. So we started out with this guy, and this is the answer you get. Order of your composition is very, very important. question on this guy? Okay. You actually have something similar. With number 6, but let's quickly take a look at that. So this is exactly what happened for us in example 4, where we were looking at those ordered pairs. If you talk about the domain of the f function, the domain of the f function is the 2, 4, and 6. But when we did the domain of the composition, you only had 2 and 4, right? And you can go back and take a look at that. We only had 2 and 4 as our domain of the composition function. And they're talking about basically not being able to use that 6, because the 6 came with the 8, and the 8 did not have a place in the domain of the g function. So they're just kind of showing you how the domain of the inside function can match with the domain of the outside function and how it affects the result. Because my outside function, which was the g function, did not have 8 as part of its domain, and that's why I was not able to use that ordered pair of 6, 8 from my f function into the composition. So domain is going to be something you're going to have to be very careful about. So the inside function, if any value is not in the domain of the outside function, you can use those. And that's going to be true for set of ordered pairs like we had here, or even if they're given to you as equations. So any value on the inside function's domain is not going to be part of the outside function. It's not going to make it into the composition. And I wonder if that's going to be something that's going to play into effect in number 6. We'll see. Yes. Domain of the inside function can be whatever. But the answers you get from that, if those answers are not in the domain of the outside function, they do not make it into the domain of the composition. Yes. And that's why that 6, 8 did not become a part, because we didn't have 8 in that outside function. Okay. All right. So number 6 is kind of similar to what you did with number 5, but they're only asking you to find f of g. They're not going in both directions. So if we're talking about f of g, what does that guy come out to be? So let's see, he is number 6. F of x is given to us as square root of x plus 3. G of x is given to us as 3x. They're asking us to find f of g. Okay, so f of g, hold on. Again, f outside function, g inside function, and what is g given to us? 3x, which means that 3x now becomes the input, right, for the f function. So that means this 3x is replacing the x here in the f. So what should we have when you make that substitution? Very good. Underneath the square root, replace the x with 3x, and then you still have the plus 3. Okay? That's the answer. Because they didn't again give us that parentheses 5 or anything like that, right? So again, they just want the general answer.
So how do you find the domain of that?
Okay, that's a good question, because that is the second part. So anybody have an idea of how we would find a domain of
Well,
that?
you know, the square root, so it has to be in the, like a 9 or.
Oh,
Yeah.
Well, not just a 9. You are on the right track, but what numbers can a square root have on the inside?
0,
And? Can. C-A-N. You said positive, but what else? positive and 0. So anything on side of a square root can be positive or 0, which means, let's do this. This part here has to be greater than or equal to 0. So just take the inside part, set it greater than equal to 0, and get x by itself, which will give us what? So you're solving an inequality. It should be. Okay, so that's telling us what our domain will be, because x can be -1 or greater than -1. So your domain,
Don't our signs change or no?
only if you divide or multiply by a negative number,
But, oh, yeah.
right? So this would be the domain for the composition f of g. And that's going to be starting at -1, and it's saying greater than, right? So that means you're going to infinity, and the greater than equal to symbol is what tells us it should be equal to.
Since we are dividing it, like that, we're not dividing by a negative.
Yes.
you know, Since in fraction form, it looks like it's -3, but that still wouldn't switch the sign, right? Just
Yeah.
because the denominator is still positive.
Yeah, so we subtracted the 3, right? But subtraction doesn't do anything. It doesn't change. But when we divided by +3. So yeah, that's why your direction did not change. Very good. Okay, so once you find your composition, and that was that first part that we did, f of g, where g is going inside of the f function. G was 3x, which means everywhere in the f function, replace the x with 3x, which gave us square root of 3x plus 3. Now, because this is a square root, and we know square root can be 0 or positive, square roots cannot be negative. So that's why we know that the minimum value we will have in there has to be -1, because if I put -1 in here, what do I get? -3, and -3 added with +3, 0. So that's the smallest value we can use. And so -1 is okay, but if I put -2 in there, I'm going to get a negative answer, which of course defeats our purpose. So that's why we know -1 is the smallest value you can use for x. Okay? Alrighty. So how you set up your problem makes a big difference on what your final result is going to be. And this is kind of what they're talking about here in this little paragraph here. So they're saying you can think of some of these complicated functions, and we've looked at them as quadratics in the previous section. So something like this function here, x minus 7, the whole thing to the second power. You can actually think of this as being a composition of two functions. So they're saying you can think of this as being one function, which is just the x minus 7, the other function, which is actually bringing in that second power. So we know from x we need to subtract the 7. We also know we need to square our entire answer. So if you take those two operations and separate them into two functions, you get your two simpler functions here. So the way we do our composition is the square function actually has to be the outside function, and the x minus 7 has to be on the inside. And why is that? Because look at x. If you put a number in for x, and let's say we're using 7, what's the first thing you're going to do? Are you going to square that number first, or are you going to subtract 7 first? You're going to subtract 7. So that's why the x minus 7 needs to be the inside function, and the square needs to be the outside function. So it's the order, and they're actually showing you what happens if instead of g of f, you make it f of g. So if I put f on the outside, that's the x minus 7 function, g on the inside, that's x squared, which means now I am going to square the number first and then subtract 7, which is not what this original function was about. So if you're not coming back to that original function, that means we did this setup incorrectly, okay? Because that's exactly what they're asking us to do in this next example is they're giving you the big complicated function and they're asking you to figure out what those simpler functions will be and then what the order in which you set this up is going to be. So this one actually is breaking up into 3 simpler functions. So here's what you have to figure out. What are the 3 different operations that are happening in this example? So start with x. What's the first thing we're doing to x? Subtracting 3 from it. So that's actually going to make one of our functions. After we do the subtraction, what's the next operation happening on that answer? Square root, which means square root. Stop doing this. Just the square root is going to make one more function. And then what's the operation happening after we do the square root? Multiplying with what?
Square root.
And
2.
times 2, right? So whatever answer you get from there, you are multiplying by 2. So those are actually your 3 operations, which means all of those operations make one simple function. So you can label them how you want to. It doesn't matter. You can go in the order of F, G, H. You can switch that order, but you have to be careful how you set it up because we need to come back to the original function. So let's write this guy down. This is capital K of x 2 times square root of x minus 3. So one function is just a subtraction from 3. One of them is just the square root, and the other is multiplying by 2. Now, if you keep it in the order of let the first guy be f, second guy be g, third guy be h. What should our order of composition be so that we come back to that k of x function?
H of G of F.
H of g of f. Okay, so this is what you're suggesting. Okay, anybody else? And we'll check that to make sure. So which should be the innermost function is what you're looking at. So k is the final result. So this would, the order that Iram gave us should basically give us the original function. So that's what we're trying to figure out is what that order should be. Should it be FGH? So f of g of h, should it be what Iram gave us or any other combination? HFG? Okay, and then again, we're trying to make sure we're coming back to the original function, so we don't know yet if it's equal to that. Anybody else want to give it a order?
F of G, no.
HGF?
I was thinking F.
HGF, so the same thing that Iram gave us?
Oh, yeah. I can
Okay.
see that.
Okay, so you are keeping the same order. What were you going to say? You're not sure? Okay, anybody else? Okay, so let's try both the orders that we have and see what do we get. So if you're talking about f as the last function, that means we're doing h on the outside, g as the second, and f as the third function, right? When you do this operation here, this order, that's h on the outside, f in the middle, g on the inside.
Where's your,
Now put the functions in and make sure you're getting what you need to get. So let's move this a little bit to the bottom here. Let's do h of g of f. Yeah, you close as many as you open. And then we had the other order here. Okay, so remember, h and g are on the outside. We're putting f as the very center function. And what did we define f as? X minus 3, which means he is going in here. Okay? So x minus 3 is inside of which function right now? G, which means g has to do the substitution. So leaving h as it is for now. If I'm making a substitution with the g function, with x minus 3, how do I rewrite this guy? Square root of x minus 3. So, you know, so far we've only done 2 compositions. This one is 3, which means we have just one additional step. So we start with f as the inside function, which was x minus 3. F is going inside of g, which means you are taking this value and replacing it inside of the g function. So instead of x inside the square root, replace it with square root of x minus 3. Okay, that's step 1. Now, since this is a 3-part problem, we're now putting this composition, which is g and f, into the h function. H was 2 times x, which means this value entire thing is replacing the x in here. So that guy will become 2 times, instead of x, what do we write? Square root of x minus 3. And does that look like the original function that we started out with? Yeah. So since we're coming back to the original function, this order is correct, which means this order is correct. So that means by changing those middle 2 functions with the f and g will probably not give us the right answer, but I do want to walk you through that step. So here, h on the outside, f on the middle, and g as the innermost function. Now, how did we define g as the base function? Just square root of x. So this is where you're going to put square root of x now. So I have f of square root of x, which means this here, x, and this x has to be replaced. So instead of x, what will I write here for my, I don't know, function in the order here, I guess. Since we're replacing x with square root of x, what does this guy become? Square root of x. So he will become square root of x minus 3. Because what we are doing in this function is we're taking this square root of x and we're replacing just this x in here. Because of that composition that you did, where g is the innermost function and f is its outer function. Okay. Now, just like we did in the last step here, this whole thing is replacing our x in here. So that guy will become still 2 on the outside, but instead of x, you're going to have square root of x minus 3. Because remember, this entire thing should replace this little x here. If you were to distribute this guy, you're actually going to look at a very different function than the one you started out with. And this is not equal to x. That order of your composition is very, very important. So this guy does not work. You will see examples of 2 compositions. You will see examples of 3 compositions in your homework. So you should be able to practice with each of them and see how those orders work out. So anytime they give you 3 compositions, why not? How would you define your each individual function? What's the first thing that's happening to x? It's being squared. That's one operation. What's the next thing you would do after you square it? Nope. Add 1. So just that adding 1 is my second function. And you'll notice I'm not writing that as x squared. I'm just writing it as x plus 1. Because the square is already being taken place with that first part. And then what's my last operation? Divided by 2. So it's going to be just x divided by 2. Yes?
Since it's why would we go x plus 1 first before we get
We would do x plus 1 first.
right? But since division comes.
Nope. This is a fraction bar. Remember grouping. So you have to simplify your numerator first before you divide by 2. That's that parentheses, the p part, right? Because the fraction bar also acts like a grouping symbol. So you do have to clean up your numerator before you can do the division. So yeah, that's why we're adding first. Okay, so square would be the first thing we did. Whatever answer we got, we would add 1. Whatever answer we got, we would divide by 2. So each operation makes a function. So the square is a function on its own. We've already taken care of the square, so I don't need to put the square back in here. This is just going to be the x plus 1. Again, we've already taken care of the addition, so the last part will be just x plus 2. So you're just always using x as your variable. You don't need to bring in the squares or the square roots. That's the same thing we did here when we defined. The first thing I was doing was subtracting by 3, right? I did not bring x minus 3 in here. I just brought in the x. Then we'll do the square root. Whatever that answer came out to be, I was multiplying by 2. So again, you'll notice I did not have a square root here on my 2x. I did not have x minus 3 with my 2x. It was just 2x. So you're always bringing in just one x because the idea is the previous steps have already taken place. So we don't need to rewrite them as you define these simple functions. So again, you can define these guys as your f, g, and h. No, you could have done G, F, H, H, G, F, however you want to do it. I just follow the alphabetical order, but yeah, I mean, you can label them however you want. Yeah. Now, the idea is labeling is fine, but the composition is the part that's going to be really crucial. So again, what should our composition be so that we end up at that capital J function again? What's going to be your innermost function? No. Yes, the starting one is going to be your innermost function. So f has to be the innermost, which would be the operation you do after you do the square.
So if we were to put it in that order, no matter what, the way we break it down, the order of operations has to be the order that we break it down to the right.
Very good. So if f is your innermost, what's your second? Very good. And then the last outside?
Yes, so much easier.
There you go. Okay, let's try it with one more example. You know what? I'm gonna do a bunch of 3s. Okay, still break it down, order operation by operation.
So,
All right.
That's enough. Okay. Times 3. Then what are we labeling this as?
Z.
Okay, I will name it Z. Yeah, exactly. Don't make it X of X.
And then V of X,
Okay.
why not? V the X plus 3.
Very nice. Single operation, right? Okay, so what's our composition now? So we're starting with G on the inside. Then he is going inside the Z function, so he is going inside here. That's 3 times x cubed. And then this whole answer will now go inside the final function, which will be 3x cubed, which is what we had to begin with. And you should be able to verify that in here also. F was x squared. He was going inside this function, so that was going to become x squared plus 1. And then both of them were going inside this function, so that would be very good. Questions on these two examples?
We do one that'll be like on the test.
Oh, I don't know what's going to be on the test. Haven't made your test yet. That's something I've left for tomorrow. Or maybe even Wednesday morning, like come to campus at 7 a.m. and go like a mad person. No, I'll do it tomorrow. Let's not do that now. Because if I'm panicking, it's not a good sign. Iram, you were saying something. No? Okay, good boy. Troublemaker. What can I say? Alrighty, guys. Let's see how we can use this. We had actually done something like this, I think, in chapter 1. But basically, they're saying, let's see how we can use this idea of composition with something we already know. So they're saying, write the area of a square that has a side of length s. And basically take that area function with the side of length s and write it as a function of its diagonal. Okay, so let's see if we can come up with this image here. What number? 8. Okay, so we've got a square with side s. So what is the area of a square? Length times width. So that would basically be, in this case, the same number, right? S times s. So s squared. So you've got area as s squared. Now, when they're talking about diagonal, that's your diagonal d. So how do we find d? Levi?
S
Like hypotenuse?
Say that one more time.
S squared divided by 2.
S squared divided by 2.
Yeah, that's what I'm saying.
That would be the area of the.
We're looking for area, or we're looking for
The d, length d.
Or would
How do
it
we find the
be
hypotenuse?
Exactly. Yeah. Yeah. And what is that called? Pythagorean theorem. Yeah. So you're actually just using the Pythagorean theorem to help you find the diagonal, which will be in terms of the side s. So for the diagonal, you're basically saying which would be the hypotenuse, right? The diagonal. So that's your d square equals s square plus s square. Since we're adding the same number s square with s square, that's 1 plus 1, which makes it 2. So you will end up with, but it's not s squared divided by 2, right? It's d square divided by 2. But before we do the division by 2, what should we do first? Yeah, since we only want a single d and not a d square, take a square root. Now, what happens when we normally take a square root? Very nice. You get a positive and a negative. But since this guy is supposed to be the length of a diagonal, we are going to ignore the negative root. So just take the square root. Nope. What is square root of 2?
There's no square root here.
Not a clean answer, right? So your 2 will actually stay.
What is it? It's supposed to be 25?
No?
No. Yeah, and your
An
S
S.
is
2s
It's
squared.
an S?
Yes.
Stop making fun of my letters. Sheesh. Or you can actually write it as s times square root of 2.
That's what I did.
So the square root of 2 will not simplify because that actually comes out to be a repeating or non-terminating decimal 1.414 and it keeps going. So leave the square root of 2 as it is, and the s, the square and the square root will cancel out, so you get one s on the outside. So how do I translate it where they're asking us to write the area as a function of the diagonal, which means a, instead of writing a in terms of s, they want us to write a in terms of d. So right now, area is defined as side times side, right? S squared. They want us to write where area is not based on side, but area is based on diagonal. So basically what they're asking us, the composition that is happening, is asking us to go from S, A to S, and S to D. So that your final result is going to be A of D. This guy here right now is A of S.
So then we gotta go
A of S to D.
yeah.
Okay. Okay, so think about that. Somewhere over here is where it's telling us how to make this change happen. So do we need to use this? Can I actually go back to this and make a substitution? Kind of look at that and tell me what you think. Jacob? What are you thinking? Fine.
What's up?
How are you going to make that transition go from A to S to D?
When you
To
use the
SCB.
S times the square root of 2, that, right, the one that you're gonna use to substitute your A.
You can. So what would you end up doing then?
Well, how do you plug in like the A and for S? Is that what you're trying to do? Like,
You will make a substitution, but not quite A substituted for S. But you are on the right path. Yeah, you can use S square root of 2 definition if you want.
Would it be D?
And do you know?
I'm not entirely sure
Okay.
where this is going.
Yeah.
Still trying to figure that out.
Confused where I'm trying to go.
Okay, so right now,
You got
this guy is, how do I want to write him? I guess he is D as a function of S. This first one, area, is function of S. We are basically trying to rewrite it as a function A, as a function of D. Okay, so when we're saying as a function of, we're saying basically what your variable is. So when I say A of S, or A is a function of S, I am saying that you are calculating the area based on the side of your square. When I have D of S, which is what we just calculated, we are saying you are calculating the diagonal based on the side of the function. They are asking us to find the formula for the area where you have to use the diagonal instead of the side as your calculation. So if the diagonal of this square was given to us and the side was not, we should still be able to calculate the area of this square. Okay? So that's what I'm asking you. Where are you making the substitution? Kate, do you know the answer to this? Not sure?
The 2x squared.
Yeah.
U square and then that
You
would get
can
rid of
use
the
that
square root.
also. So yeah, you can use this definition. You can use this definition. It's really entirely up to you. So right now we have area as S squared. We also have diagonal squared, s2s squared. And we have diagonal as d equals s times square root of 2. You can make these substitutions wherever you think is going to be the most convenient for you. If you want to use this second one, get s squared by itself, which means divide both sides by 2. And you will end up getting s squared equals d squared over 2.
Hold up.
Mm-hmm.
No, those are 5s, right?
Yes.
Okay. Because I don't know, I wrote 5s.
I
I'm
am even
confused.
calling it s squared, so why are you
I don't know.
seeing 5? And my s does not look like 5.
That's how I
Does
wrote
it?
my 5s.
That's how I wrote my question.
Oh, shush.
That's how you write her.
I am not even listening to
I never
Aaron
used
anymore.
S before.
No, they're all s's. There's no 5 in here, so just assume.
Doesn't
They're
say
all
no
S's.
5.
Because, yeah, don't confuse yourself. Make sure you correct that if you have 5s on your paper.
2s look like Z's.
We need to find a writing teacher, the actual writing, using a pen and writing, to help all of us out, apparently. Okay, now if I rewrite that second function as b squared divided by 2 equals s squared, do you see where the substitution can happen then? Where?
So you just substitute the s squared in the area formula. for
Which will
d
give
squared
you
over 2.
d squared over 2. So this is where the substitution will happen. You can substitute area with that s squared instead of s squared. We know s squared equals d squared over 2. So that means you can actually write a as d squared over 2. A as a function of d, because what is it using as its variable now? The diagonal, not the side. That's the answer. If you go with this formula here, it's actually going to get you to the same result. But we would basically be undoing what we just did. Same thing, get s by itself. But now this is s squared, right? Which means you just end up squaring. And this is kind of what you were thinking with that very equation. So this would then end up giving us d squared. Square cancels out the square root. And then you would be back at this place. So you can use any of those versions to help you come up with a in terms of d.
Is that a D?
That is a d.
Okay, it looks like a 2.
Well, the denominator is a 2. I must really not know how to write.
Wait,
Which one are you talking about? This
the
guy
last
here?
one. Yeah.
Yeah. Oh, now I'm in red. I don't know. So either of those routes will take you to the answer. So you can leave it at the d squared equals 2s squared and do the substitution from there. If you get d by itself, basically that process is we got rid of the square, but then we have to bring back the square. So that would be the only difference if you went with that second part right there. Okay. Yes,
Where it goes from blue to red,
right here.
where it goes from d over square root of 2.
This guy.
Where did we get the 2 for the x?
So since we know a is defined as s squared, and this is a single s right now, to make it into a square, we're bringing in,
Okay.
yeah, because we're just trying to match it to
Okay.
that. Yeah, so this square is coming from the a's definition. Yeah, very good. What else? Okay, I think we have one more application. Oh, this one is talking about the revenue of books, from the sale of books. So the revenue is $80 for each book that is sold, and that function is given to us as the revenue function, R of X. equals 80 times X. So basically the idea is the X represents the number of books sold. And then for each book sold, you're getting a revenue of $80, right? So that's 80 times X. They're saying the commission for that revenue is going to be X dollars. So that is commission C of X. And they are getting 0.10 for each book. Sorry, not book, because X here is now the number of dollars. So for whatever dollars you are getting from the revenue, you're getting 10% as your commission. So how much are you making off of each book? If you're getting a revenue of $80 and 10% is your commission.
$8 per book.
Yeah, very good. So what they want to know is how can you write this as a function? And they're saying express the commission as a function based on the number of books. So here's what's happening. In the commission function, this X is the number of dollars. In the revenue function, this X is the number of books. So even though we're using the same variable X, it means two different things for the two different functions. For revenue, X is the number of books. For commission, X is how much money did you make or how much is your revenue. So they are basically saying, instead of writing the commission function based on dollars, they want us to write the commission function based on the number of books, which we know should be $8 per book, right, as your commission. So how would you make that composition happen so that C of X function, that X is number of books and not how many dollars? So what's the order of your composition? What's the outside function and what's the inside function? And the inside function would then be the revenue. Yeah, the R function. Very good. That's exactly what they're asking you to do. Okay, so C of X, whoa. Where X is your dollars. R of X is our revenue function, where X is the number of books. So if you're doing the composition as C of R, which would be this little order, what would you end up getting? Nope, because you're just doing multiplication. You're putting R inside of the C function, right? Which means you're taking this guy and you're putting it inside for just the X. So what will that become? No, I'm just looking for the function definition. So how would you write this guy out?
0.10 times EX.
Very good, yeah. So that, remember, the X gets replaced with 80X, which then ends up giving you 8 times X, and this is your X as the number of books. Because what you did was where X was representing the dollar amount, you're replacing that with the 80X. And this 80X is coming from the revenue function, where X was the number of books. So your commission function now has become based on dollar number of books instead of just a dollar amount. You're still getting the same commission, but you're just rewriting the function. So this is what your composition ends up looking like, where X is your number of books. So now if we told you that we sold 100 books, what's the revenue? Just the revenue. What did they make if they sold 100 books? No, because 100 books, your
It was sold
revenue,
100 bucks.
8,000. Yeah, because you're selling 100 books, you're making a revenue of $80 on each book. So on $8,000 of revenue at 10% commission, what would you have? 800. Okay. So now if I take that same 100 books in this composition function, what's my commission? 100 times 8 will give us 800. You're getting the same answer, right? But now you just did the composition, so we didn't have to calculate the revenue separately, then put the revenue into the commission function to find that. Now I can just say I sold 100 books. That's $8 commission on each book. I make $800 as the agent. Okay, so that's basically what the composition is doing.
Are they always gonna be doing that, making two different X's?
Yeah, that can happen. Yeah, the X does not always have to be the same variable. So it can happen because,
Good question.
it just kind of depends on what the application is. Sometimes it can be the same X value, but a lot of times it can be two different X
Can we
values.
leave like CX as X and put RX as Y?
Yeah, you can change that variable. So you would make it R of Y, but then your final answer, when you did the composition, no, would become Y then. Because since we were putting, if you're calling this guy Y, then this would also change to a Y. Okay, so I believe that was the last example for whatever this is, 2.4? All righty. You guys should have your 2.5.